In this video, we're going to continue our discussion of custom function definitions, this time with a function that has multiple parameters. Now, to save a little typing time here, I'm going to go ahead and paste in the function definition. We're going to define a function here called maximum, which receives 3 parameters because it wants to figure out the largest of 3 values. So as you can see, I started with the def keyword followed by the name of my function, a parameter list, this time with a comma separated list of names which become the parameters, and the colon then introduces the body of the function, which again is called a block. Now, the first thing inside of any function definition should be a docstring, so we've provided one here, which is saying that this function will return the maximum of 3 values. And as we did back in the control statements chapter, we're going to make a little simplifying assumption here, which is to say that value 1 is the maximum value so far. So max value is assigned value 1. Then we're going to use a couple of if statements to figure out whether value 2 is greater than max value, and if so, assign value 2 back to max value. And we're going to check if value 3 is then greater than max value, and only if so, assign value 3 to max value. Now you'll notice we're violating a little bit of the Python style guide at the moment by not putting a blank line above and below each of these control statements. And there's a reason that we did that. When you're inputting a function definition like this directly in IPython, if you press enter, you get a blank line, as you would expect. But if you press enter again, saying, let's say you wanted to start a new control statement, it's going to assume when you press enter twice that you're done with the definition of whatever it is you were just creating, and it's going to then evaluate the snippet of code. So if we were to have gone ahead up here and pressed enter to drop to the line that currently starts with if, and then pressed enter again so that we could start the if statement one line further down, we actually would not have been able to complete the whole function definition in that case. So that's just something to keep in mind when you are working in the context of the interactive interpreter. Now, once we get past the 2 if statements, max value contains the largest value so far, so we're going to use the return statement at that point to give back the largest value to whoever calls this function. So let's go ahead and execute that, which defines the actual function. When you execute a function definition, it creates the function in memory. The function itself, by the way, is actually an object, and the docstring happens to be a piece of data within the object that represents that function. And when you use the help system, it goes and looks at that object and accesses the docstring piece of data to get the string that you defined as the docstring. So let's go ahead and call this function that we defined. So we named it maximum, so we'll start with that. Remember, when you call a function, you need parentheses and typically are going to need arguments. So usually when you're trying to figure out the largest of 3 values, it's typically going to be 3 items of the same type. So let's use 3 integers here, and you can see that the result is the largest of those 3 integers. Let's try it again with some floating point numbers. So let's do 12.3, and we'll do 45.6 and 9.7. So this time the largest value is in the middle position rather than the 3rd position, but we just want to make sure that indeed it gives us back the largest value each time. Now, before I continue, one thing that's interesting about the maximum function and about Python in general is that, again, we have not specified what the types of value 1, value 2, and value 3 are. Python figures that stuff out dynamically for you. So as long as you can assign whatever type of value you're dealing with, and as long as you can compare with the greater than sign whatever types of values you're dealing with, those values will work with the maximum function. So it turns out, for example, that the maximum function has, I'm sorry, not the maximum function, the string type has the greater than operator defined for comparing strings of information. So for example, I can go ahead and take the maximum of, let's say, yellow, red, and orange. Now I'm using all lowercase letters on purpose at the moment because when you start dealing with case sensitivity, strings are not considered to be the same. So you have to be careful with that, and we'll talk more about that subsequently. But right now I have these three strings, and if you're thinking about strings alphabetically, O comes before R and R comes before yellow. So yellow is the largest, if you will, of the string values, and orange is the smallest of the string values based on alphabetic order in the alphabet. So if I go ahead and run that, you can see that indeed it gives me back yellow in this case. And I'll talk more about the case sensitivity issues in subsequent lessons. That's beyond the scope of what I'm doing at the moment. The main thing I wanted to point out here is that you can compare strings using greater than or equal, less than or equal, double equals, and not equals as well. So that just demonstrates to you the fact that we can go ahead and compare lots of different types of values, provided that they support the greater than operator that we're using in the context of the maximum function in this case. Now you can call maximum with values of different types, provided that those types are compatible with one another. So if I do, for example, 13.5 minus 3 and 7, we've got one floating point number and two integers, and floating point numbers and integers are compatible with one another. So I can go and figure out that 13.5 is indeed the largest of those three values. On the other hand, if I were to use decimal objects and floating point numbers, that would not work because decimal objects and floating point numbers are actually not considered to be compatible with one another. So you can mix types in certain scenarios, which is also part of the flexibility of the Python language. Now, once again, the capability that I'm showing you here is something that's actually built into Python, which is why it's so important that you spend time looking at the online documentation so that you can learn about the features that already belong to the language and to the Python libraries, and even do some research into other open source libraries as well, because chances are in the Python community someone has developed a library that does some of the capabilities that you need, or that implements some of the capabilities that you need in your own applications. So for example, as I mentioned previously, the max function is built in, so I can do things like use the max function to compare some strings here. So let's try yellow, red, orange, and we'll add in a couple more here. Let's do blue and green, just to show you that it can receive any number of arguments. So we did 5 in this case, and yellow is still the largest of those three values. And similarly, there's the min function, which takes any number of arguments. So let's do some integers. Maybe we do 9 and 27 and 14, so 4 integers in this case, and you can see that it happily figures out the minimum of the values that we supplied. So again, you're going to want to take a look at that online Python documentation at python.org to familiarize yourself with all those built-in functions, because there's a lot of convenience functions already available to you, and you're going to want to take a look at the top level of all those different libraries that are part of Python, so that you can start getting a sense of the full set of features that are available to you.